Have you ever just stopped and wondered what the world really looks like on a scale so small you can't even imagine it? Well, today we're diving into the tool that unlocks that entire hidden universe, the microscope. We're going to see how it takes something totally invisible and brings it into brilliant, sharp focus.
But first, let me ask you this. What do you think the most ordinary, everyday objects look like when you zoom in, like hundreds of times? It's a world that's completely alien, and yet it's literally right under our noses.
Okay, take a look at this. What are we seeing here? Is it some kind of jagged mountain range? Maybe a weird abstract sculpture? Go on, take a guess. Got any ideas? Believe it or not, this is the edge of a serrated knife. Wild, right?
Seeing something like that is only possible because we have special tools. These instruments, they're our key. They're what lets us peel back the curtain and reveal a hidden world, a whole other dimension of detail that our eyes just can't see on their own.
When you boil it all down, their entire job is just that. They make the invisible visible. It sounds so simple, but the technology that makes it happen? Absolutely brilliant.
So, the specific tool we're going to get to know today is the compound microscope. This is the classic workhorse you've probably seen in a science classroom, and it is responsible for just countless incredible discoveries.
Now, to really get how this thing works, we have to understand one key word: magnify. Magnifying something means you make its apparent size bigger, but you don't change its physical size. That is such an important distinction. The microscope isn't actually making the object grow. It's just bending light to make it look bigger to our eyes.
All right, let's dive into this machine. To really get a feel for it, we're going on a little tour of its parts. And we're going to group them by what they do. You've got the parts for seeing the image, for focusing it, the parts that hold everything together, and of course, the parts that light it all up.
First up, the optical system. You know, the real heart of the microscope. This is where all the magic happens. You start with the objective lenses. Those are the ones right down by the specimen doing all the heavy lifting, magnifying anywhere from 4 to 100 times. Then you've got the eyepiece up top where you look. And that rotating turret they're all mounted on, that's the nose piece. You just give it a click to switch between different powers.
Let's just zero in on the eyepiece for a second. Think of it like the final portal. After light has made this whole journey up through the microscope, this is the very last lens it goes through before that image hits your eye. It is your personal window into that tiny, tiny world.
Now, having a huge, magnified image is pretty useless if it's just a big blur, right? That's where the focusing system comes in. You've got two main knobs, the coarse adjustment and the fine adjustment. They might look kind of similar, but trust me, they have very different jobs.
So what's the deal? Well, the coarse adjustment knob makes big, fast movements. It's for getting you in the right ballpark, and you only use it on low power. The fine adjustment knob, on the other hand, makes these tiny, super precise changes to get that perfectly crisp, sharp image.
Okay, next up is the support system. This is basically the skeleton of the microscope. It all starts with the base, which gives it a solid foundation. The arm connects everything together. And this flat platform here, that's the stage. That's where all the action happens, where you place your slide.
And right on the stage, you've got these little guys, the stage clips. Their job is so simple, but it is so important. They just hold your slide firmly in place so your amazing view doesn't wiggle around while you're trying to focus.
And finally, you can't see what isn't lit up. That's the job of the illumination system. There's a light source at the bottom, and then there's a diaphragm. The diaphragm works kind of like the pupil of your eye, controlling exactly how much light gets through to the specimen. Too little, it's too dark. Too much, and the whole image gets washed out. It's all about finding that perfect balance.
So, we've seen all the parts. Now for the fun part. Let's put it all together. How do these pieces actually create an image? Well, to figure that out, we're going to follow the incredible journey of a single ray of light. So here's how it goes. Light starts at the source, at the very bottom. It shoots up through the diaphragm and the stage, and then it passes through our specimen, lighting it up. The objective lens, sitting right on top, grabs that light and creates the first magnified image. That image then travels all the way up the tube to the eyepiece, which magnifies it again just for you. And that is the crucial takeaway right there. It's a two-step magnification process. The objective lens and the eyepiece are a team. In fact, that teamwork is what makes it a compound microscope. It's how it can make something look up to 1,000 times bigger than it really is. Knowing how it works is awesome, but knowing how to use it properly is absolutely essential. These aren't toys, they're precise scientific instruments. So let's quickly go over the most important rules for using one safely and effectively.
Okay, here are the 4 big ones, the non-negotiables. 1. Always use a slide and a little cover slip. 2. You always start on the lowest power objective. Always. 3. And this one is critical. Never ever use that big coarse focus knob when you're on high power. You can crash the lens right into the slide. And 4. Always carry it with 2 hands.
Let's just really hammer home that most important technique. Start low, then go high. You find what you're looking for on low power, you get it perfectly centered and focused, and only then do you click the nose piece to a higher power for that closer look.
And whenever you need to move it, this is the only way to do it. One hand has a firm grip on the arm, and the other hand is flat underneath the base, supporting all that weight. This is how you prevent drops and expensive damage.
So to wrap it all up, it really comes back to this one central idea. It's all about the partnership between those 2 lenses. One captures the image, the other enhances it for your eye. It's such a simple, beautiful system, and it's what unlocks the entire microscopic world.
You know, from the tiny cells in a leaf to the little crystals in a grain of salt, there is an entire universe of intricate, invisible wonders just waiting to be seen. Now that you know how the tool works, the only question left is, what are you going to discover?